so section 9.6. Okay? What the main idea here this week is I am going to give you a written out a written out equation. And I am going to ask you to either identify a certain part from that equation, or I'm going to ask you to graph that equation. Okay? Now, they're going to be all kinds of mixed up. Okay? Meaning they're going to come from circles and parabolas and ellipses and hyperbolas. So on this particular slide, I have the standard form of all four of our conic sections. Okay? So that's what they all look like. Okay? It is your job this week, and what you will be learning and dealing with this week, to determine from the given information what each particular equation is an equation of. Okay? So, how do we differentiate between them? Well, the easy one to figure out is the parabola. The parabola is the only conic where only one variable is squared. On the other three conics, both x and y are squared. In a parabola, only one of them is squared. Okay? So it's easiest to figure out the parabola. Okay? The second easiest is the hyperbola, because the hyperbola has a subtraction sign between the squared terms. Okay? So if it's x squared minus 4y squared, that is a hyperbola. The hard one is determining what between a circle and an ellipse. And what you look at is you look at the coefficients on the squared terms. Okay? If the coefficients on the two squared terms are the same, it is a circle. If they're different, it's an ellipse. Okay? So those are your four different ways, or three different ways really, to determine what kind of tonic we have.
Can you write out an example for that middle one?
The next four slides are, yep. So yes, we will. But I want you guys to get this written down first. Okay? So, classify the conic section represented by the given equation. Okay? So, in A, okay, in part A, or in example A, I should say, do we have one squared term? We have two squared terms, right? We have an x squared and a y squared. So automatically, parabola is gone. Okay? In A, parabola is gone because I've got an x squared and a y squared term. Okay? So the first one, done. Second one was if there's a subtraction sign between those two. Okay? There is a subtraction sign right here. So that means that this conic is this is a hyperbola. What's your thoughts on B? So it's so that one's a parabola because there's only one squared term. So this one is a parabola. C. How many squared terms? 2 squared terms. So parabola's gone. Okay. Got an x squared term, got a y squared term, so the parabola's gone. There's a addition sign in between the squared terms. So hyperbola is also gone because it's not a subtraction sign. So then I look at the coefficients. Okay. What's the coefficient on the x squared term? Coefficient on the x squared term. 4. Coefficient on the y squared term. 1. Are those the same? If they were the same, it would be a circle. If they're different, it is an ellipse. Because of this right there. Example D. Squared terms, 2 of them, so parabola's gone. Addition sign between the squared terms, right? So hyperbola's gone. Coefficients are 1 and 1, so that makes D a circle. Bless you.
Thank you.
Yeah. Now, the other part of this one is just straight up writing those different equations that we have for them. Okay? And we've been doing them almost in every section that we've had. So I'll give you a couple of minutes here to do E and F. Write me the equation of each of those conic sections. Circle. A circle is x minus h quantity squared plus y minus k quantity squared equals r squared. So this one would be x minus 3 quantity squared plus y minus negative 2, so that's y plus 2 quantity squared equals 16. I got to square the radius there. Yes? Okay. Parabola, there's 2 different kinds of parabolas. This one has a vertex at -2, -4, and a focus at 4, comma, -4. So that tells me that it opens to the right. Agree? And that's y squared type of one. So that's going to be y minus k quantity squared equals 4p times x minus h. Yes? Okay. So that's going to be, this distance in here is 6 which is my P value. Distance from the vertex to the focus is 6. So that tells me then that this is going to be y plus 4 quantity squared equals 24 times the quantity x plus 2. Agree with that? Questions on either one of those two? Two more for you. Gotta unfreeze it first. There, now we're good. Phew. What? You'd be grounded a lot, yes. Okay? So we got a vertice there and we got a vertice there. What can you tell me about having two vertices in those two spots? The center is the midpoint of those two, right? Okay. So that tells me then that the center is at the point 3, 5. Negative 1 plus 7 is 6, divided by 2 is 3. 5 plus 5 is 10, divided by 2 is 5. Okay? So the center is at 3, 5. Yes? Okay. Having foci here, and here is also helpful. Okay. So the foci distance was C, correct? What is C? 2? The distance to the vertices is A in an ellipse, and that was what? 4. What's the formula that we use in ellipses? For A squared equals B squared plus C squared? So 16 is going to equal B squared plus 4. So B squared is going to be 12. You gotta square it. The equation of an ellipse is x minus h squared over, in this case, it's over a squared, plus y minus k over b squared equals 1. So my ellipse in this case is x minus 3 quantity squared over 16 plus y minus 5 quantity squared over 12 equals 1. A is 4, distance from the center to a vertice. That distance was 4, so a squared then would be 16. Okay, and to find the foci, we use a squared equals b squared plus c squared. And so c is the distance to the foci, that's 2, so that squared is 4. So 16 equals b squared plus 4. Subtract 4 gets me 12 equals b squared. So that's why b squared is 12. Questions on that one? hyperbola now. Vertices at 7, -3, and 7, 1. That also tells me what? Seven, what did you say? -1? Yep. Foci at -6 and +4. Okay. So this distance here is what in a hyperbola? Nope. It's B, right? And what is B? 2. This distance out here is what? That's C. And what's C equal to? 5, isn't it? What's the foci formula that we use with hyperbola? So I don't have A. B is 2, so B squared is 4. C is 5, so C squared is 25. That means that A squared here is 21. Now, which way does this hyperbola open? Up and down, right? Okay, so is that x squared ones, x squared minus y squared, or y squared minus x squared? Y squared minus x squared? Okay, so then my formula is going to be y minus k, quantity squared, over b squared, minus x minus h, quantity squared, over a squared, equals 1. What?
Oh, sorry.
Oh, okay. So then this is going to be y plus 1 quantity squared over 4 minus x minus 7 quantity squared over 21 equaling 1. Yes? Okay. Tonight, I have selected a few problems for you to do. Get back into that nightly homework type of thing, rather than have one big assignment towards the end of the week. We'll have 3 assignments this week, each due then the next class. 13, 15, 17, and 19. Yeah. None of them are very long.